Today we are going to talk about an extremely simple strategy. How do we, in an automated fashion in Python, identify such regions of stock consolidation and breakouts so that we can trade these breakouts? I'm going to help you define a function in Python which is going to identify such areas of consolidation, and then we are going to backtest this on Bitcoin data. And we are going to look at the results of our backtests. And finally, at the end of the video, I'm going to give you a few tips on how to improve this even further. As you can see, this trade using a breakout at this time gave us a win rate of 75%, which is pretty awesome. And the returns were much better than the buy and hold returns. So let's jump right in. So what is a consolidation? A consolidation is a region where the stock is trading in a very small range. And this is a argument of a function which is how much percentage change are we going to allow in this region of consolidation. And once we identify this region of consolidation, we're going to take a long position and we're going to wait for the breakout and then just sell the stock once we hit our take profit or stop loss. So if we want to take a trade somewhere here, and then we are just going to take a take profit here, for example, and set a stop loss here, and then wait for the stock to hit either the take profit or the stop loss. So that is the meat of our strategy. Let's first define the Python function, and that is the main sort of topic of this video. Just to recap, we start always with this Bitcoin 5-minute data set, and this data contains each candle here, which we have the open, high, low, and the close of the candle, and each candle is has a duration of 5 minutes. As you can see, the interval between successive candles is 5 minutes. So this is 5, 10, 15, and so on. So we are going to take this data and we define a look back period, and the look back period basically says what is the window of time where we expect this stock to be in a certain range. So in this particular case, the look back period is this. So in a 14-day time period, is the stock within a certain range? Is the stock trading within a certain range? And the range is what we define as a threshold in this function. So in the consolidation function, we pass two arguments, which is the data frame itself and the threshold. And then when we call this function, what we are going to do is, so we defined the, so we are going to pass a data frame which has a, which is between like 14 days from now and now, or 14 days from now and 1 day from now. So this contains sort of 14 candles. That's the idea. Okay. So once we pass this data frame with the last 14 candles, we are now going to ask, we are going to call this consolidation function, and we are going to ask if there is a breakout signal and what is the true range that the stock is trading within inside that breakout, inside that consolidation signal. And we set a very small threshold, which is, let me see, 0.15%. That's correct, right? Yeah, 0.15%. And I set this threshold by basically looking at a few different thresholds, but again, like for your own data, for your own sort of financial instrument, check what works for you. And let's see. So this function, we look at the mid values, and the mid value is like the mean of the open and close. So this is like open plus close by 2. Open plus close divided by 2. Okay, so what we want to see, we want to look at the maximum value that the mid of the candle reached within those 14 days. we want to look at the minimum value that the mid of that candle reached within 14 days. And then we define the percentage change. If the percentage change is less than the threshold, is consolidated true, else the inconsolidated is false. It is as simple as that. And so at each moment in time, we're going to look at sort of 14 days of data. So if I have, so here, the first call to the function will look at this window of time, let's say. So between like so 14 is probably somewhere around this. So we're going to call this function for this small window of time, and we're going to ask is this function consolidated within this area. So this will probably return false, and then we are going to move this by 1, we're going to move this by 1, and then we're going to again ask is this consolidated, and we're going to keep on going like this, and each time it will return false until it goes here, and the right end of the window goes here, and the left end of the window goes here, and this is the point where we return true. And so we ran this function on our data set, and we identified, so we looked at the first 1,000 sort of values, first 1,000 candles, and we identified like 1, 2, 3, 4, 5, 6 breakouts within that region. And so are these, what we expect? Are these doing what we expect them to do? So we take the first breakout, 576, that's the index when this happens. And then the true range is what the function returns. And so we plot the candlestick patterns, and in previous videos I've explained how to do that. And then on top of the candlestick patterns, I'm going to plot the true range, the minimum and the maximum of the true range. I'm also plotting like 50 data points before the breakout and 100 data points, like 50 data points after the breakout. So these 100 data points, which are where the breakouts is sort of somewhere in the middle. So I'm plotting this so that I don't plot, like if I plot a large number of data, like it's really hard to see what's going on. So I'm plotting sort of 100 data points around the breakout identified, and then I'm showing you the region where the breakout happens. And clearly, visually, we can see that, yeah, like there is a very small movement within like these 14 sort of candles, which means that there is a clear consolidation. Again, we look at a second example. So 923 is sort of another index where this returns true for us. Again, we see sort of a similar thing. Now, you might wonder, like this looks like a larger sort of region. The problem is when we make these plots, like the range of this y-axis is larger than the range of this y-axis here in this second plot, which is why this looks like a sort of a larger sort of change, but we know that this change is in a very small sort of region, like 0.1% or 0.15% basically. So that is our function. So now that we've done this, what we can do, we're taking the first 7,000 data points here, and we are now going to test our strategy. And our strategy is extremely simple. It's so simple that you would think that it may not work. The strategy simply says, if you identify a breakout, you go and take a long position. And it doesn't matter, a lot of people are going to look at, the end of the breakout and trying to see some signals if there is if there is a chain movement on the either end. And so, but this is like much simpler than that. This is saying anywhere within the breakout, even if we identify somewhere here, like 14 days happens to be somewhere here, like the moment 14 days of breakout happens, you just take a trade and you go long. So that is the strategy. So to execute this strategy, we are going to add one more column to our data frame, which is the small df, which we have copied like the first 7,000 data points. We're going to append this column, which is called breakout signal, which is by default going to be false. And then again, like if we're going to again like iterate through all the sort of rows of this data frame, and if we don't have enough rows to look back, we simply continue. And then we define the look back as 14, but again, it's a parameter that you can sort of optimize depending on your data, but we haven't done it here. And then we're going to take this small data frame, which is we call TF look back, which is the last 14 sort of data points. We're going to call this consolidated. And if the consolidation is true, actually we are looking for, so if the consolidation is true, we are looking to see if there is a bullish move upwards. In other words, we have two conditions. One is that the consolidation is true, and then the open of the next candle is above the breakout sort of range. So that gives us some confidence that the breakout is bullish. So the problem with consolidation and breakouts is that this could go either in this direction, like a bullish direction, or it could go sort of in a bearish direction. We don't know which one. So this gives us some confidence that if the open of the next candle, which is this candle here, is above the maximum value of the breakout, that tells us that this is sort of going towards the bullish direction, and we can take a trade in the bullish direction. So that is the meat of our strategy. We are saying that if the consolidation signal is true and the open of the next candle is above the breakout, the maximum value of the range within which it was trading, we put the breakout signal as true. And then we look at how many times it was true. In sort of 7,000 sort of data points, it's barely true for like maybe 15 times. 16 actually. We counted how many times the breakout signal is true. It was false for like 6,984 times, and it was true only 16 times. And then we define our strategy, which we call the breakout strategy. So how do we execute the strategy? In order to explain that, I have to explain the backtesting library. So if you followed my previous videos, you know that I've built a backtesting library, which I keep on using to test all of my strategies. I'll link both in the description and the video itself, the backtesting library, and feel free to sort of check out that video to understand how I built it. For the purposes of this video, let's understand that in the backtesting library, we define strategies, which all derive from a base strategy, and each strategy basically says what is our entry condition. So a random strategy's entry condition is very simple. We get a random number. If the random number is 1, we buy if we have enough cash. And then our exit condition is always that we try to close trades in every candle. And when we say try to close, this basically means that we either reach, if we reach a take profit or we reach a stop loss, we're going to try to sell. So with that being said, let's think about what the breakout strategy does. So the breakout strategy has a different entry condition. So in the random strategy, our entry condition was if the random number is 1 or 0. In the breakout strategy, we ask that the entry signal is whether the breakout signal is true. So if the breakout signal is true, which basically means a couple of things, it means that stock consolidated for last 14 candles and current open is above the consolidation range. And if that happens and we have enough cash, we are going to buy. So let's see what happened when we did that. So for these 7,000 data points in Bitcoin, we took a cash which would allow us to buy 1 Bitcoin. So Bitcoin was trading around 760, 770K. So this would allow us to buy 1 Bitcoin at a time. And then we run this backtest and we see that this is a time when the buy and hold return was minus 8%, which means that the stock was not, or Bitcoin was not doing very well in this period. But this breakout strategy, extremely simple breakout strategy, was able to give us a return of 3%, which is amazing. It's 11% above the buy and hold strategy. It's a positive return. And if you compare it to other strategies we have tested in this channel, this is a pretty good strategy. Also remember, the strategy does not do any optimization. There is one optimization parameter in the strategy, which is the look back window, but we don't actually do any optimization. So now we've done the back testing, we've got a win rate of 75%. Let's ask ourselves, what more can we add to this strategy? We can always make a strategy sort of more complicated. We can add stuff to this strategy. One big question is, if we have a breakout, are we going to break out in the bullish side or the bearish side? So this is sort of one question that we've tried to answer in the simplest possible way. We've said that, if you think that the open here is larger than the breakout value, then we're going to break out on the bullish side, which may or may not be true. In this case, it's sort of barely above the consolidation value, which you can see here. So one possible improvement is to understand what was happening before the breakout. If there was a strong uptrend before the breakout, like here, that may be an indication that after the consolidation ends, the breakout will be sort of in the same direction. So that may be something you want to sort of incorporate in your own sort of strategy execution. And again, you can download this notebook and change the code in order to do that. The other obvious thing is to look at this 14-day period and say, can I run my optimizer? I've taught in different other videos about how to sort of optimize these parameters of these strategies. So you can try to optimize that, and that may be a second sort of improvement over this very simple breakout strategy. I hope you enjoyed this video. Please like and subscribe if you want to see more such backtests and executions of Python trading strategies. Thank you.